Okay, guys, let's get started. Let me welcome you at our second data science series of lighting talks. And let me start with some intro into our company. So you will learn something about STRV first
There's
before diving
nothing
to
like
talks.
introducing something new to the world. Something yours. And getting there by being that one persistent optimist in the room. That's what we were back in 2004. A tiny team as far removed from Silicon Valley as it gets. Crazy enough to aim straight for the top before our own name meant anything. No investors, no guidebook, no friends in high places. But we knew that if we went the extra mile, again and again, we'd shape not just an incredible team, but the futures of people as passionate as we are. And now, this is STRV. Hundreds of projects, decisions that have left an undeniable mark on entire industries, clients turned years-long partnerships, all done with people who found their way to each other because we love our craft, and we do it justice by helping others with their own new beginnings. What we're saying is, we got you because we get you. We understand what it takes to put everything on the line. That's why we respect the people that go for it, and why our team will always do what's right for your vision, especially if that means doing what's never been done before.
So now I hope that you know STRV a little bit better, right? And now I would like to use actually a similar kind of video to tell you something about our team, because Martekin was so kind to create another kick-ass video for us. Let's dive in.
Data science or an expensive experiment for businesses is now vital for gaining a competitive edge. I think our field is all about real-world expertise, creativity, and I believe that there's always a solution for any problem, no matter how complex. This philosophy enables us to use state-of-the-art technology and build data-driven products to solve the most pressing challenges our clients face. Nowadays, there's mainly recommendation engines, chatbots, predictive analytics, fraud detection, data analysis, data engineering. There's a lot. I am proud to say that the solutions we built to solve all of these challenges have a proven immediate impact. Our team takes care of the entire process for our clients, from identifying use cases and defining success criteria to building a proof of concept and implementing the final solution. What I find most exciting about our work is seeing people benefit from cutting-edge technology, which our clients sometimes think is out of reach, but which we get to use to make their dreams a reality. Being a part of this journey is incredibly inspiring.
Okay, before diving into slides, I have one last slide actually. So do not hesitate to ask questions at the end of each talk. So just shoot. We will be also reading those online questions and trying to answer those as well. Then after main event, after our talks, there will be a networking sessions. Feel free to ask anything or direct message us later on, and or reach us at social medias, right? We also publish blog, send newsletter, right? And we are hiring, so feel free to ask about open positions. Okay. Lukas? Thank you.
Hello everyone, my name is Lukas Koucky. I'm a machine learning engineer at STRV, and my talk will be about Edge AI. So to answer the question, what is actually Edge AI? I will tell you about the project we were working on last year. It was content moderation for social network. So we wanted to approach this problem as usual, to build some machine learning algorithms, some neural network, put it on a backend, create some API to call it, and then send videos there for content moderation to find out if there's something inappropriate in the videos and to block them in case there is. But then we find out that if we transfer our standard TensorFlow model to TensorFlow Lite, we can save up to 80% of the size, we can speed up to 80% the computations, and we lose few percents of accuracy, sometimes even no percent. So we can actually put this model directly into the phone, into the application in the phone, and embedded it, so we don't need to call the API. And that's actually what is HAI. HAI is running the AI and ML algorithms on the device, on the end device, on the user devices. So you may ask why to do it. Is it really a good idea? And I think it is a good idea. First of all, because of the latency, because you don't need to wait for your request to be calculated on some backend, get the results back. There's a zero latency, everything is running on the device. Another advantage is, for example, real-time analytics. If you have some data-heavy model that you can run directly on a device, you don't need to send all those data somewhere and wait for the calculation. And if I go back to the example of the social network, sending all the videos somewhere to be processed and then get back, it can be also quite heavy. But when we are running the model on the device, we can actually run the model in parallel when the user is recording the video. So we can do the content moderation in parallel when recording, and once the user is done with the video, we already have the results, and it's much better for the user experience to have the results immediately. Another great advantage is scalability, because when you are growing from thousands to millions of users, for example, scaling a backend can be an issue. But when your model is running on the device, it's not an issue at all. Security and privacy is another great advantage, because when you have some sensitive data, you don't need to send them anywhere. They can stay on the user's devices, and you don't need to be afraid about some data breach or sharing the data with some third-party services. Everything can stay on the user devices. And reduced costs. It goes hand to hand with the scalability, because again, as you grow, you don't need to scale your backend. You don't need to pay much more for the computations on some servers or anything, because the model is running on a device. So again, you may ask, okay, this seems quite good, but how is it in practice? How difficult it is to deploy the model for some mobile device? So it's quite easy. I have an example here of converting the model to Core ML, which is Apple's native model that you can use for all the iOS devices or any other devices in the Apple ecosystem. And it's just 4 lines of code. So you load the model, you convert it, and in a few seconds you have Core ML model that you can use. And it works pretty fast and pretty good. If you want to stay with TensorFlow, you can use TensorFlow Lite. Again, it's just 4 lines of code to convert the standard TensorFlow model to TensorFlow Lite. If you prefer PyTorch, then it's fine. PyTorch Mobile is basically the same as TensorFlow Lite. It's super easy to convert, and it's very similar. And if you want to try something new, there's ONCs, which is also a great way to serialize your models and to run them anywhere, basically, because with ONCs you can run them on mobile devices, IoT devices, or any Linux, Mac, or Windows. So yeah, I've been talking mostly about mobile phones and mobile devices, but HAI doesn't mean only those. It can mean also IoT. So you can run your machine learning models even on some small IoT devices like Raspberry Pi or even smaller. Here's some examples of, for example, object detection on Raspberry Pi. And you can see that with TensorFlow Lite and Raspberry Pi Model 3 B+, you can run for MobileNet version 1 something like 4 frames per second for object detection. But with only 1 year younger Model 4, you can run more than 10 frames per second, which is quite good for any object detection in real time. And here's some more examples of what you can do on the edge. It's a fish that is driving its own tank. So there's a camera on top of the tank that's looking at the fish. There's some object detection running, and everything is running on the Raspberry Pi. And when the fish flows to the right, then the whole car is driving to the right, and the fish flows to the left, the whole car is driving to the left. And it's just some nice fun project you can do directly on the device. Yeah, and that's all from me. Thank you for listening, and if you have any questions, feel free to ask.
So you showed the advantages of having it centralized in the device, but there's also disadvantage when you need to do some upgrades, for example. So your model has changed, and now you need to update it to hundreds of thousands of devices. So how do you handle that?
Yeah, that's a great question. There are basically 2 ways how to do it. For example, in the mobile apps, you can deploy the new version of mobile app and have an upgrade, and that's not the best way to do it. Of course, download those new weights on the fly when there is an update like this. So it's possible to do it without your user even noticing that something's happening. It's a little bit more difficult, but it's definitely doable, and it's fine.
Hello. How resource hungry is the AI on the mobile phone? Because usually on the server you have a lot of resources, CPU, RAM, and so on, but the mobile phones are usually quite limited in this way.
Yeah, that's of course is the issue, but with each new generations of phones, it's better and better because they are getting almost as powerful as laptops a few years ago. So, for example, when I mentioned the social network we were working on, we can do the object detection and the content moderation during the recording of the video, and it's completely fine with all the latest iPhones up to few generations back, and they can work normally during it. We don't have any. I don't have any benchmarks to tell you. I don't know any thresholds. But at any new phones for Android or iOS, it's pretty possible to do anything.
Great presentation. In regards of online training, have you thought about how this could be done with the Edge ML? How we can get data back to the server and retrain the model and redistribute it back?
That's a great question. We were also thinking about even training the models directly on the devices, but that's something for the future. It's maybe a distant future. But what we do now is we send some results of the moderation, some metadata of the results back to the server and use them for improvement. So when I get back to the example of the content moderation, we have the video stored at some server. We have the moderation results done on a device, and with the metadata about the video, they are stored in a database. So we have the video, we have all the results, and then we can use it for some updates and for some retraining and for anything.
Who was the other one? You? Okay.
Hi, thanks for the talk. I was wondering, you had some models there, like the mobile net and so on. How big are these models in terms of size, like megabytes and so on?
Yeah, for example, the mobile net I showed you, it basically was developed to be run on a mobile, hence the name. And the smallest model is like 2 megabytes. And if you can scale up, yeah, there's also, of course, trade-off between size and accuracy. But you can go under 10 megabytes for some pretty decent models. So, for example, we are using something like 8 megabyte model. And if I compare it to, let's say, 100 megabyte model we had in a normal TensorFlow, we lose just 2% of accuracy.
Yeah, there are also some quantization techniques, right? So
Yeah, there are a lot of steps you can do. For example, TensorFlow, when you are converted to TensorFlow Lite, does most of it in the background, but you can decide what you want to do. Of course, you can go from 32 bits numbers to 16 bit numbers, or even to 8-bit numbers, and you can do some quantization. You can even do some quantization on training data that's supposed to help it. I don't understand this one much, but the quantization helps a lot to scale the model down, really, even up to 80%.
Yeah, the second part, you can actually use dataset to decide what connection to drop, and getting rid of some weights. So that's another technique. Okay. Any other question? Okay, let's go online.
Okay, thank you.
No. It's empty. Okay, sorry. Okay, thank you, Lukas, for the talk, and let's welcome Jozef, our data engineer.
Hello, everyone. Welcome to my lightning talk. My name is Jozef, and I'm the first data analyst, data engineer at STRV, but I rather call myself analytics engineer. I'm curious, how many of you know what analytics engineer means? Okay, one. So hopefully after today's presentation, there's going to be more of you. So today's topic is modern data stack, a topic close to my heart. And I hope that my slides will tell you how this was born, what it means, and how it can help you. But first, let's go through the history. Starting in the 90s, databases back then were run locally in a local server room, and were mostly row-based. This meant that they were slow and expensive to run analytical queries, so that wasn't ideal. Luckily, there was a solution, which was running ETL processes and then building all-up cubes to serve the metric data. This, unfortunately, meant that there was a huge vendor lock-in. It wasn't very flexible, because you couldn't just rerun the whole cube if you need to. And of course, it was expensive. This setup, I'd like to call it a classic data stack. And right now I would like to tell you a bit how it looked in a day of a regular data analyst. He was using for storage SQL Server, usually. He was running ETL on top of Microsoft services, so SQL Server integration services. And then he was creating all-up cubes using SQL Server analysis services. The real life of data analysts, therefore, was something like this. He found out that he doesn't have the data in the warehouse, so he went to the data engineer to create ETL process to get it. Afterwards, he must, of course, have a model to serve it. So he went to the BI engineer to create an all-up cube for him. And after these guys were done, he finally could prepare the report or dashboard. This summed up in total to 3 full-time employees. Each of them worked for example, 20 man days. So in total, it was 20 man days. And then afterwards, of course, you get a feedback loop back from the business if the report is fine, or if they want to do some more changes. That meant another circle of effort needed. This wasn't ideal, but unfortunately, these days, some data teams still work like this. So now let's move on into the present and the future. In 2012, Amazon introduced Redshift on top of their cloud services, which basically meant that storage all of a sudden got cheap, compute got fast and cheapish, and the tools that were used for it were still a bit more expensive. But the great thing about it was that all of a sudden, analytical queries, which were summing up the columns, for example, were very fast and efficient. And also, term called ELT was born. This is not a typo. It's basically a change in paradigm where you don't lose the raw data while doing ETL process. You rather extract, load it into the warehouse, and then do the transformation inside the warehouse itself. The benefits of it is that you get to keep the raw data. So whenever there's a new business case to use the data, you have it there ready to use. As I said, the tools were still expensive. So luckily, open source stepped in. And in 2017, dbt was born together with the term analytics engineer. dbt is basically a combination of SQL and Jinja, meaning that it gives SQL superpowers with for loops, ifs, and so on. That meant that data analyst is now able to do data pipelines without any kind of data engineer needed. Just so we know, the difference between data engineer and analytics engineer is mainly in business understanding. For example, data engineer usually is very technical, doesn't understand the business. He just wants to have some technical description of what he needs to do and get ready to do it. On the other hand, data analyst usually talks to a business a lot, so he understands it. But previously he wasn't able to create data pipelines. So now, all of a sudden, analytics engineer is capable of understanding the business and at the same time create the pipelines. Luckily, dbt was also built as a platform. So there are open packages for dbt. This means, for example, that if you use Stripe as a payment service, you basically can reuse the package and get the data from it and model it in a usable model just by using the package. Another part which was still expensive was the EL part. So again, open source stepped in with Meltano. The name is basically a shortcut for model, extract, load, transform, analyze, notebook, orchestrate, which is too long. And is basically, the tool on its own is basically on a mission to cover the whole story of a data team. So they want to do extract and load, transformation, and even do orchestration and analysis on top of it. It was started on a leftover technology called Singer. This was started by a company called Stitch Data that makes extraction of data, but is regular business with pricing. They at one moment thought that it might be a good idea to standardize extractors and loads, so you can use them as you would like to in any combination. But after some time, they left it around and they didn't invest that much time into it. Luckily, there was a team in GitLab with Meltano, and they took over this initiative. So right now, the most beneficial part of Meltano is that they are maintainers of Meltano Hub, where most used tabs or extracts are managed. So now we have basically a modern data stack put together. So let's look back at the example of a data team and what technologies they use and how their day looks like. For storing, we are using column store database, such as Snowflake. Then we are using open source ELT, for example, Meltano together with dbt. And since the databases are so good at running analytic queries, the BI tool can directly run the queries on that database. So the real life of analytics engineer looks like following. He checks his warehouse if he has the data. Luckily he has. So he just creates the new pipeline, and afterwards he creates a report. In total, this means around 20 man days. So basically we just did the same work with just 20 man days. As I'm describing this, I'm getting to a problem that I see in most of data teams' life, which is problem number 1, expectations. Many managers of data teams and business owners and so on go to the data analyst and ask them if they can pull that data real quick. Just a regular question, but this happens many times. What does the data analyst do afterwards? He just selects all from that ideal, clean, and pristine table that you think exists, and just provides the data, of course. That's how it's done. Unfortunately, that's not reality. The data, as it's stored, doesn't cover any use case and is not ready to use. So what do you say to the manager? You just say that one does not simply pull the data real quick. So this part was modern data stack actually meant that the data team got more efficient. So afterwards, the whole community could build on top of it. And last year, in 2021, dbt covered another part of the data team life connected to metrics. So they introduced dbt number 1, which includes metric layer. By metric layer, I mean definition of metrics that used to live inside every application that the business or machine learning engineers or data science used. So every tool that was using metric had different definitions, and this basically meant that many times these didn't match. So dbt introduced metrics layer, meaning that this is centralized, and each tool can just take over the metrics as it's defined in dbt and will share the same number. This is what I like to call problem number 2 for the data team, connected to accuracy. Many managers can spot a number that doesn't match his intuition. So you regularly get into a situation explaining to the manager that the number in your report is correct, and he's not right. Therefore, you as a data analyst spend a lot of time just checking out the numbers if they are correct or not. I have a suggestion to data teams of how to deal with this. I regularly suggest that every data team should have a form where you would have this question. What is more important to you? If it's getting the answer quickly or getting an accurate answer. This is because Pareto principle applies here, that you basically spend 20% of your time getting 80% accurate number. And if you would like to get 100% accurate number, you need to spend another 80% of the time. So that's all from the history part. It's 2022 and I'm in STRV, so how are we doing? This is basically our data stack. We are deploying our stack on Heroku. We are using Meltano, dbt core, which is open source. We are orchestrating everything through Airflow and then showing the metrics and the data using Metabase. So that's it from me. Thank you very much for your attention, and if you have any question, feel free to ask.
I wanted to ask, have you tried any other tool than Airflow to orchestrate the pipelines?
Not yet, but we are aiming to. We would like to try Dexter. Dexter is going to be also supported by Meltano itself. So. Okay.
Any other one? Don't be shy, guys. Okay. You're my favorite one. Asking a lot of questions.
Thanks. I just had a very brief look at Meltano. I didn't know about the technology. And it seems like it's basically a lot of configuration files where you put in all kinds of operations. So I was wondering if there is some kind of extension, something like this, that would work directly from some programming language like Python. I think it's preferable to use a full-fledged programming language where you can use all the nice things as code completion and so on, and don't have to check documentation to an extensive project and so on. Like, do you have some recommendation like this in this direction?
Can I ask back, what position do you work in?
I'm mostly machine learning, yes.
Okay, that's what I was aiming for. Like, you're used to use Python, but imagine that Meltano is supposed to be used by data analysts, which are basically SQL based mostly. So they don't necessarily need to use Python. In Meltano, they just use YAML files, which are quite easy to work with. And then, as I said, combination of SQL and Jinja. So it should be as easy as possible to just have a code in a text file that can be version controlled, but doesn't necessarily need that much of a programming language itself.
Yeah, I was just thinking that you lose the ability of advanced IDE tools like code completion and these things when you work with text files like that. That's my main criticism, and I was asking if you know about some tools that would do this.
I see. I'm not aware of at the moment of any, and I'm really not looking for it because I like this kind of combination. So
I think that the configuration is actually pretty simple, right? So there's no point, of having some auto-completion in that case.
Yeah, by the way, for example, there is extension for VS Code text editor for dbt. So for example, the code completion for dbt is already possible through that extension.
Okay, thank you. Any other question? Okay, let's check YouTube. Empty. Okay. So in that case, thank you, Jozef, and we will have Niek.
Hey guys, nice to meet you all. I am Niek. I'm working in STRV as a machine learning engineer since last August. I am enjoying it quite a bit, just so you know. I think it's a great company and it's a great opportunity to work here. My presentation will be about serverless ML, and ML in this occasion stands for machine learning, just so you know. I think the serverless ML is a very good solution on many occasions, and maybe less good in several others, but more on that later. In case you're wondering, you might not know what serverless ML or more generally serverless computing actually is. Many people seem to think that it is computing without a server. So there's some magical unit somewhere that does the computation somewhere, and we don't really know what it is. So like this, right? Symbolized by this symbol, it says no server. But actually, it's not what it is. Just to inform you, there is for sure a server somewhere doing the operations. So I put a very simple definition for you. You can read it yourself, but it basically says that the developer does not have to manage the server. So what it means is that you, as a developer, you can spend all your time on important stuff, right? You want to write your own code, you want to develop your own program. You probably don't want to spend that much time on maintaining servers, on doing redefinement, especially in the cases when you are operating a very simple model, right? Many things are not really needed, I would say. This kind of service is FAS. Function as a service, in case you're interested in the terminology. Next up, so what are we talking about? My personal experience is mostly limited to AWS, and they offer AWS Lambda, which is basically the name that they give to their serverless application. In case you're not familiar with AWS, there's also Azure, supported by, or a function supported by Azure, or function by Oracle. They're not so creative when it comes to their naming. So I will quickly describe for you 3 benefits and 3 unfortunate disadvantages of doing serverless computation. We'll start with the benefits. First of all, there is a reduction of DevOps, which basically means that you can save money as well as time on programming stuff beforehand. When you go serverless, there's almost nothing that you have to define pre-deployment. Secondly, you're pay as you go or pay on request. It means that you only pay for what you're using. So this can be an advantage and also a disadvantage. It will be an advantage for people that say are on the low to medium number of requests per month. And to put a number to it, I think that means that you do around 0 to 2 million requests each month. Then it will be a very good solution for you. In case you are going higher, then maybe it's better to get a server somewhere that you do predefine to do your calculations. Thirdly, you're scalable. So I hope that by now you understand that we are basically talking about the definition of scalability. You have a machine, if you want more, you can get them. You can just infinitely multiply your machine and get as many as you want. So you might think that's all good, but there are also a few disadvantages, I would say. And to what extent they are bad, you can probably define that for yourself. First of all, there is a very strong restriction in size. In the case of AWS Lambda, where my personal experience is, let's say, limited to, you are restricted to a maximum of 50 megabytes that goes with your code upload. So that is for sure enough for linear regression, for some other neural networks too. Actually for many neural networks too. But you might want to go bigger. And if you go bigger, I don't say that it's not possible. You might as well use an S3 bucket or some other cloud storage for it. You can do it, but you're limited when it comes to the upload of your code. Secondly, there are hardware limitations there. So as I told in the first slide, you are on a server somewhere and you are bounded by its hardware. And in the case of AWS Lambda, it might not be state-of-the-art. It might not be the best that you can imagine. And thirdly, you are restricted in time. And in my case, it was like 5 minutes. So for machine learning inference, I would say that 5 minutes is enough for, in most cases. If you want to do something that is, I don't know. Maybe you want to train a model on a serverless computing instance. I don't know. But then it's maybe not the best solution. I will now illustrate serverless computing with an example of my previous work. So TF Lite, I think that Lukas already spoke about it. TF stands for TensorFlow. And they offer this TF Lite service that's basically a very restricted version of TensorFlow itself. So when doing this on AWS Lambda, you are restricted to 50 megabytes. This goes well with TensorFlow Lite. Many of the models can be packaged to this type of model, and it will, in most cases, be definitely less than 50 megabytes. So you can convert it to this, and when you do so, it's also wise to minimize the use of other packages. You might want to use pandas or NumPy for some data preprocessing. In case you want to use them, just be aware that both of them take up space, so pick one and not two. In the case of TensorFlow, its total size would be, I think, half a gigabyte, which is way more than the 50 megabyte that Lambda restricts you to. So think about it and be as small as possible. So for a client, I took this EfficientNet model, in case you guys know it. Basically, it's a model that takes a video, and when it sees the video, it spits out a vector of 1,000 number, each symbolizing object that was with probability that it was seen in the video. In my case, this was like a URL. I feed the URL to the Lambda function. The vector comes out, and you get these numbers, which in my case I invoked by HTTP request, but also many other solutions are possible. You can think about probably an email service that works really well, or AWS Lambda or AWS pipelines. Everything. There are many options to invoke these functions. That was it. So in case you have questions, please ask.
Hi. First of all, good talk, thanks. And the second, there was a deployment model. So practically you wrap your application to the Docker and you deploy the Docker and let your model run in it?
That is correct.
Okay. That's it?
That was it? Okay.
Any other one? Okay.
Would you agree that another disadvantage of AWS Lambda is how you can debug it? Like getting it to the IDE and just go line by line?
Definitely true. I would debunk it locally. I guess does that answer your question, or I guess the debugging on Lambda is not the easiest thing, so I would probably not even bother with it.
So you will not even bother to or you find it easy to do it?
No, I do the debugging on my local machine, and normally if it works on my local machine, then I deploy it, and then it normally works just like that.
Okay, thank you.
You can think about it as, writing some ordinary Python functions in the end, right? Any other question? How about you, Michal? Okay. So in that case, let's check our YouTube feed. Still empty. What a pity. Okay. Thank you, Niek. Let's dive into our last talk, which will be covered by me. And I will tell you something about concept drift. Have you ever heard about this one? Raise your hand. Okay. We have one guy. Or okay. So what the fuck is concept drift, right? Okay. So by the way, just to give it an intro, so this is a really interesting topic that is pretty much neglected in academia, and it can really screw up your model in production. Because what if I told you, you know, your model will turn into garbage? So it's usually this way. As soon as you deploy your model into production, it already, it's usually already underperformed. And, it really doesn't matter whatever it is, like, some Excel linear regression or some fancy machine learning model, like some deep learning model is this efficient. It usually already degrades. Because all of these things has something in common, They were usually trained using some data, and concept shift is about data and some assumptions about data or some changes in the environment. So actually you have really a nice picture of two distribution to illustrate this thing. So imagine that you're training your model, you're fitting your model on this distribution, but in production your model is actually facing something like this, right? And this can actually happen, and it happens quite a lot, and it's usually caused by some changes in the environment. So I will get to it later. And as another thing is that those assumptions might not hold anymore, and I will also cover this one. But in the end, you might be losing money, right? Because the performance is not as you would expect it, and it's getting worse and worse because of changes. So it's actually a real thing, and I have a really nice illustrative example. We all love COVID, right? So actually, COVID is a great example that illustrates this concept shift drifting. So here's like a model to predict demand for example, face masks. So before the COVID, the model was pretty stable. So you might have some peaks, for example, during some seasons, like some flu seasons during winter, right? And then, national lockdown was announced, and suddenly, the demand for for masks went up, and all of these systems which were, basically predicting the demand were completely off, because of the concept drift, because of the sudden change in the environment. So that's one example. So, for example, predicting stock. You might have some seasonality, right? The things happen, new products are introduced on the market, etc., etc. But yeah, another examples are, for example, some adversarial environment. So, for example, fraud detection or stock markets. So people are constantly competing, introducing some strategies, how to make money out of you. So this is also a great example when you need to deal with concept drift somehow. And maybe the last one is, not the last one, but also like a huge category, is, for example, using a non-representative data set. So to give you an example, let's, for example, use a facial recognition algorithm. Imagine that you would train your model on European to recognize faces, and you would train the model on European faces only, right? But somehow your manager would decide, to deploy that model like in North America. So in that case, you would also face, some biases introduced by training data set and the fact, that the model was trained on completely different distribution. So it's, it's also a really nice example to illustrate it. Yeah. But there is actually a solution, and that's a good thing, right? Though, first of all, in order to be able to detect concept drift, you need to monitor, and monitor. So very important is to do continuous model monitoring, and it's not just about tracking some standard software metrics like latency, availability, right? But it's also about tracking data, inputs and outputs, and also measure models KPIs, so you can actually detect some drops in accuracy or whatever metric you decide to use for that use case. Important part of this is to store data. You would use for inference, or you're using for inference in production to store predictions like those inference results, and also some metadata, right? Like model, circumstances where this prediction was made, etc., etc. And once you're able to collect all the necessary information, you can take some appropriate measures. By the way, I would recommend this nice source, Machine Learning in Production, because it covers, it basically covers, this whole monitoring pipeline, and it also covers some concept how to deal with concept drift, concept shift, and much more. So now you're able to detect concept drift. So your model is decaying over time. You can tell by visualizing those KPIs. So one really simple thing to do is, for example, to retrain, right? So at some point, for example, accuracy drop under a certain threshold, you decide to deploy a new model. Yeah, and it actually works, right? But it might not always be the solution. You need to, for example, take a different step, right? You need to, for example, fix a model, introduce some fixes. You might even have some, backup plan. Like, for example, having much simpler model which use more bias and is, for example, better at dealing with the current environment. Or, you can take completely different approach, right? But as long as you collected all those information, it should not be a problem, to actually detect. And as always, you can just take new data and retrain, right? But this approach still somehow assumes that we have static environment, and actually we can do better, right? So this might not be the best optimal strategy, as for example, some business manager as your boss. If I know, if I can interpret this graph, this plot, I would ask you, why can't we have like a constant line, right? So instead of getting those drops, you can somehow evaluate it with thing that is based on idea of online or incremental learning. So basically, this branch of algorithms, this approach, it embraces the change. So, and especially it solves the issue with delay. So the model is updated constantly as soon as you actually decide to do so, as data are available. But it solved the issues with delays, with the drops, but it actually introduced new complexities. Like you suddenly have to balance between exploration and exploitation usually. So taking into account, what you already know versus what you can know or what you can find or what has changed. So that's one thing. And it also more machine learning ops heavy. Yeah, that's basically it. So do you have any questions?
Questions?
Thank you, Nick.
Okay, so what you propose is like proactive rather than reactive mitigation of this problem, right?
Yeah, but it also depends on the problem, right? Some problems might be static, some might not require that often update. So I would say that it's really problem dependent. But for example, we are dealing with recommendation engines, and in that case, it makes perfect sense, to have proactive approach because, for example, trends on social networks are constantly changes. So it's a problem dependent.
And thanks for mentioning that. So what is the key how to know when to act proactively rather than reactively or the other way? So is it the costs or is it the business values or what's the key here?
I would say it's business value and understanding the environment that you're going to deploy your model to.
Okay, thank you.
What is your opinion on modeling the concept drift and trying to model the concept drift? Do you think it makes sense?
I would say, it sounds more like a meta machine learning, but in that case, it's even quite hard to get to online incremental learning. Not to even mention that some teams are not even ready, to retrain their model periodically or even detect concept drift. So I would say this is really, like a future topic, far away topic, more of an academic discussion.
Okay, thanks.
More questions?
Just I've never heard the term MLOps, so maybe if you could just give an example how online incremental learning introduced the MLOps complexity and what it entitles.
So machine learning ops is just another buzzword or term, that is actually DevOps focus on machine learning. So this is gonna be like a big thing, maybe let's say 2 years in the future.
Nothing else? Michal?
So on one slide, there was a stock chart. So you are saying that this concept can really predict trend of the market, right?
No. It's not about predicting concept of the market. This presentation was about that it's really hard to predict trend of the market.
Yeah, but the question was, if you try, how accurate it was,
Yes, so we actually, when we are dealing with concept drift, it's usually on some recommendation engines. Other than that, we don't have that much experience with it, but with recommendation, it's like a really big thing because, it's like, COVID masks all over again every day almost because, new topics are rising, so you need to react somehow, your model is already, old in that really quickly changing environment. We actually also did one project, and it was aimed at fraud detection. And actually, we were able to, prove to show clients some value by combining online learning and active learning in that environment, because it was also constantly changing. Fraudsters were developing some new strategies, how to fraud users. So.
Okay, thank you.
Okay, I guess that's it. Do you have any general questions, maybe on some previous topics? Michal? It's getting old, right? Okay, Nick, could you please pass the mic? Like the concept drift, yeah. So it's for recommendations and fraud detection. Okay, so for example, right now we are working on new recommendation engine for a dating app, and that's the end goal, right? To introduce some online incremental learning algorithm, but we need to get to that. So first, it's about really going step by step, iterate, right? To develop like first baseline simple solution, then move to retraining, and once we're done, we can introduce this. But yeah, and regarding other projects, would you like to ask also about other projects? Yeah. Okay. Yeah, STRV is basically agency, so we are helping clients to solve their projects, to build their products, and they might have like different requirements, different needs. So I would say that we are solving usually some it's not about working on some internal projects really, but it's helping clients to apply machine learning on their project. So imagine a social network come to us and ask us for recommendation. That's where we applying it, or doing content moderation for those social networks, or building data warehouses so they can crunch and analyze data. So these are the use cases. Any other questions? Okay, guys. So in the end, I guess networking can begin. Enjoy. Thank you.